We're still on notes 7.1. The directions are to rewrite each side of the equation as a single exponential expression of the same base, then solve the equation by setting the exponents equal to each other. We're trying to use the property of equality here. Property of equality says if we can get both sides to have the same base, right now this is 27, this is 9, then we can set the exponents equal to each other. As far as bases go, I can convert 27 to have a base of 3. I can convert 9 to have a base of 3. 27 as a base of 3 would be 3 cubed. So this was already raised to an x minus 2 that's going to go on the outside. 3 cubed, 3 times 3 is 9, times 3 is 27. 9 can be written as 3 squared. It already has an exponent of 2x plus 5. So we are in the right neighborhood right now. Then we would like to get rid of these parentheses. So we're going to use the power to a power property. So you multiply the exponents. So 3 times x is 3x. 3 times a minus 2 is a minus 6. Over here on the right, distribute the 2 in the power to a power property. We're going to get 3 to the 4x plus 10. Now the property of equality says if you have one term on each side and they have the same base, that means the exponents have to be equal to each other. Therefore, 3x minus 6 has to equal 4x plus 10. From here on out, it's simple. It's just a linear equation. I'm going to subtract 3x from both sides, subtract 10 from both sides, and get x is negative 16. Let's do another. We want 1/4 to have the same base as 8. I don't see any way to make the 8 a 1/4 or the 1/4 an 8. There are ways, but they're complicated. Let's focus on the base of 2. So first of all, let's change this so it's not a fraction. So I'm going to make this 4 to the negative 1, which is raised to the x plus 2. Then I'm going to change this 4 to a 2 squared. So that's 2 squared to the negative 1 to the x plus 2. There are lots of ways to do this. So the power to a power property, we're just multiplying these together. So it's going to be 2. 2 times negative 1 is negative 2. Negative 2 times this is going to be negative 2x minus 4. Over here on the right, I want to change the 8 to a base of 2. 2 times 2 is 4, times 2 again is 8. So that's going to be 2 cubed is the same as 8. And then I can use the power to a power property. So I'm going to multiply the exponents. Now at this point, I can use the property of equality. If I have an equation in which it's one term equal to one term, and the bases are the same numbers, I can set the exponents equal to each other. Therefore, negative 2x minus 4 is equal to 3x minus 12. If I add 2x to both sides, I get negative 4 is 5x minus 12. And if I add 12 to both sides, I'm going to get 8 is 5x. Therefore, x is 8/5. Let's do another. All right, so we got lots of things happening. This square root is the same thing as saying to the 1/2. I want this 4 and this 2 to have the same base as a 2. I'm going to change this 4 to 2 squared. It was already raised to a 2x minus 7, and that is being raised to a 1/2 because that's what the square root means. Simplifying the left side a little bit, I'm going to multiply a 2 times a 2x minus 7 times a 1/2. When you're multiplying 3 or more things together, you can multiply in any order. So I'm going to multiply the 2 by the 1/2. 2 times a half is 1. So that's just going to make this 2 to the 2x minus 7. On the right side, power to a power, multiply the exponents. I'm going to get 2 to the 3x minus 3. Property of equality says that if I have one term equal to another term, and they have the same base, I can set the exponents equal to each other. Therefore, 2x minus 7 is the same as 3x minus 3. If I subtract 2x from both sides, and then add 3, I get x is negative 4. Lovely. Thank you, sir. May I have another? I'm going to get everything to have a base of 2 here. So on the right, let's focus on that first. That's going to be 2 squared, that's the same as 4, to the 3x plus 1. Power to a power, I'm going to get 2 to the 6x plus 2. On the left, I'm going to change 16 to be 2 to the 4th. 2 times 2 is 4, times 2 is 8, times another 2 is going to be to the 16th. And that's already been raised to the x plus 2. The denominator, I've got an 8, which is 2 cubed, and that's already raised to the x minus 1. Power to a power property, multiply the 4 times the x and the 2, I'm going to get 2 to the 4x plus 8. And the denominator, power to a power property, I'm going to get 2 to the 3x minus 3. Using the quotient property, if I have a fraction and there's one factor on the top and the bottom and they have the same base, I can write the base one time, take the top exponent minus the bottom. 4x minus 3x is 1. 8 minus a negative 3 is like 8 plus 3, which is 11. Now that I've got each side to be one term and it's the same base, I can set the exponents equal to each other. So x plus 11 is equal to 6x plus 2. If I subtract x from both sides, and subtract 2 from both sides, and then divide both sides by 5, one of my favorite things to do, I get x is 9/5. Let's do one more. It says consider this equation. 2 to the x plus 3 equals 1/2 x to the plus 1. Solve this equation by rewriting each side with the same base. Yeah, so same directions as the last one. I don't know why I even have these directions here. So the left side is already 2 to an exponent. I want this 1/2. I'm going to reciprocate the base, and then I'm going to make that a negative 1. Let me explain that because I didn't do a very good job. If I want this base to reciprocate, I need to change the sign of the exponent. So I can go another route here. Let's reciprocate it and change the sign of the exponent. It's going to change both of those, a negative x minus 1. You can reciprocate a base anytime you want as long as you change the sign of the exponent. Now, those parentheses, by the way, aren't needed. I can set the exponents equal to each other because it's the same base equal to the same base. And then doing a little algebra, as they say, I'm going to get x is negative 2. Lovely. That's the end of this video. The next one, we are going to look at how to solve an exponential function using a calculator.